Good morning, children. In the previous class, we had done an activity for circular motion and rotational motion, right? We'll continue with the same activity and we'll see a different type of motion there. So you already tied the string to the bob or the bead. So now what you do is this time you tie the free end of the string to a rigid support above, okay? And then allow it to suspend freely. Now, when the bob is suspended freely, pull the bob to one side and leave it. Okay. Then observe how the bob moves. What type of motion is this? Okay. This type of motion is what we are going to study next now. And that is oscillatory motion. So, oscillatory motion is a type of motion where the object moves back and forth about a fixed point. Okay. That is, the object is in oscillation. This is something very common. You have seen swing, where children enjoy playing on the swing. So what happens, that the swing is attached to a fixed point, and about that fixed point you have the child moving, okay, or the blank of the swing moving, okay. So it's termed as oscillatory motion. Even the pendulum of a clock, that also works in the same principle of oscillatory motion. Now, oscillatory motion and vibratory motion are similar. The only difference is that in case of oscillatory motion, the motion is slow. But if the oscillation becomes very fast, okay, then it becomes vibratory motion. It's something similar. Now, like for example, you've seen many musical instruments where there are wires and we pluck the wire while playing, right? So when we pluck the wire, what are we doing? We are actually starting a vibration in the wire, okay, or we are setting the wire to oscillate. But since the oscillation here is happening very fast, okay, we term it as vibratory motion. You can see here, when this wire is plucked, then you can see these are the vibrations that move in either directions, because both the ends are having a fixed point, okay, and the musical instruments that work on this principle. Now we have the periodic and the non-periodic motion. Periodic, as the name suggests, it happens, or the motion repeats itself after a regular interval of time, like we spoke about the pendulum clock, right? So same thing again, this also comes under oscillation only, but the thing is that oscillation happens at regular interval of time, then it becomes periodic motion, okay. But in this case, even the arms of a clock will come under periodic. It's not only oscillation, it could be any type of motion where motion repeats itself after regular intervals of time. So like the clock, then rotation of the earth or revolution of the earth, okay, it keeps on repeating after a fixed interval of time. So it is termed as periodic motion. Non-periodic motion is all the other motion which is not repeating at regular interval of time, will be considered to be as non-periodic. Now next we have here is random motion, which is motion in any direction, and even the speed of the object keeps on changing. Like for example, molecules of a liquid are in random motion. Even molecules of a gas are in random motion. The direction and speed is not the same. You see in nature, birds moving, birds flying, okay, also that is also in random motion. Sometimes you do find them make some formations, okay, but otherwise many a times the motion of these animals are random. Many a times we see that when an action is performed, there are more than one type of motion that are involved, okay. That is what we term as multiple motions. Like for example, this girl is riding a bicycle and she is going in a straight line, so termed as translatory motion, and the wheel is also moving circular and is rotating around the axis. So rotational and circular motion are also into play. Same thing here when we draw water from the well. The movement of the bucket is in a straight line, so it's translatory. And also here, this wheel is moving in a rotational motion. Okay. And now here also you see there are two examples of multiple motions. One is a pendulum, okay, which oscillates, okay, and the same pendulum when present in the clock, it becomes periodic motion also. Then you also have this earth rotating around its axis and revolving around the sun. So here also there are two motions involved, rotation and the circular motion around the sun. Okay. So now let's recapitulate. We'll just see the different types of motions in the following examples. A motion of a swing, which is an oscillatory motion. Then a plucked string of a guitar, same oscillation becomes very fast and it becomes vibratory motion. Motion of a spinning wheel will be again rotatory motion, right? A car moving on a straight road is showing translatory motion as well as circular rotatory motion. Okay, the wheels of the car are rotating. Motion of a train on a straight bridge, okay, will be translatory again. A stone falling from a certain height is translatory and rectilinear, right? And movement of a wheel again will be circular and rotatory. Yes. Now we come to the end of the chapter, and you just read the chapter, children, and when we send the notes, you'll be writing down the notes and other question answers. Thank you.